Greetings and welcome to the PLSQL channel, a series of video trainings in the Oracle PLSQL language. My name is Stephen Feuerstein, and I'm a PL/SQL developer, just like you. This lesson is part of my series on programming with collections, Oracle's array-like structures. And this lesson focuses on nested tables, one of the three types of collections available to you in PLSQL. Some quick reminders. First, if you haven't already done so, go to my PL/SQL Obsession website, toadworld.com/sf. On this website, you can click on Demo Zip link and download all of the files that I'll be using to demonstrate techniques and also provide reusable code and performance analysis scripts. If you see me running a file in these lessons, you can find it in Demo Zip and use it yourself. Click on Trainings, Seminars, and Presentations to access the PowerPoints behind all of my lessons. In addition, make sure you're comfortable with the material covered in the previous lessons in this series: Introduction to Collections, Defining Collection Types, and Collection Methods. Then you should be in good shape to learn in detail about nested tables. So, what is a nested table? Well, there are three types of collections in the world of PLSQL: associative arrays, nested tables, and V-arrays. Nested tables are those kinds of collections that are defined with the following kind of type statement. And the type statement is type, and the name of the type is table of the data type. That's when you see a type declaration like this, you're talking about a nested table, and according to the documentation, it models or contains an unordered set of elements. From a theoretical standpoint, a nested table is a multiset, which means that, like a relational table, there's no inherent order to the elements in that set of data, that list, and duplicates are allowed or are significant. Now, from a practical standpoint, it turns out there is an integer index that you can use to access elements in the nested table. So there is an implied order to the elements. But Oracle also believes that you should be able to work with nested tables as if they were sets of data, like a select statement. So even though inside the nested table you've got a list of elements and they have no inherent order to them, which is what you see here: apple, pear, orange, apricot, pear, or whatever, my list of fruits. There's also implied and available to you an integer index that you can use to iterate through the contents of the collection and even access elements at a given location. So a nested table is a sort of a hybrid in-between kind of data structure. Theoretically, it kind of looks like a relational table. It's just a set of data. Practically speaking, you have the option when you're working with a nested table to work with it as a set or work with it as an ordered list of elements, which I guess is good. So, overview of nested tables. The nested table collection type was added in Oracle 8 as part of the object model. So when Oracle added object types, they also added nested tables and a third collection type, V-arrays or varying arrays, to fill out the object-oriented approach to PLSQL. Nested tables aren't necessarily a part of the object model, but they're often used in conjunction with it. You can define a nested table type and therefore the variables or the nested tables based on those types. You can define them in PLSQL in a block of code or at the schema level for use in SQL. You must initialize a nested table before using it, and I'll go into more detail on the next slide regarding initialization. And you must extend to make room for new elements. You'll see examples of the extend method in this lesson, but there's also a separate lesson on collection methods which goes into much more detail on extend. So let's take a look at initializing nested tables. Before you can use a nested table that is a variable declared on a nested table type, it has to be initialized. And what that means is that you have to call a constructor function, which is a function with the same name as the type and provided by Oracle, to initialize that nested table. There is one exception to this. If you're populating a nested table from a bulk collect query, then you do not need to initialize first. Oracle automatically initializes it. So let's take a look at some examples. I declare a nested table type called numbers_t. It's a table of numbers. Then I declare a variable called salaries, which is a nested table based on the numbers_t type. And then right inside my declaration, I can also initialize it with a call to a constructor function of the very same name. And I can provide a list of values if I want to, or just nothing. And it will initialize, in this case, a null or empty list. In my second example, I declare my type again, list of numbers. I declare my variable, I declare the type, and then I initialize it, and right away provide 3 different values. So you can provide the elements in the list in a comma delimited format, and they could be numbers, in which case, since we have numbers here, they could be more complex structures, like object types or other collections, all initialized right within that one statement. Finally, if I want to, I can put off the initialization into the execution section. So I declare the type, I declare the variable based on the type, but not until the executable section begins, do I actually call the constructor function and assign the values. That's fine, as long as you don't try to use that collection before it's initialized. If you do, you'll get an uninitialized collection error, which I'll show you in just a moment when we look at an example. So initialize first, call the built-in constructor function. You can't create your own constructor. You can only use the default one provided by Oracle, which is a bit different from object types, in which you can create your own overriding constructor functions. Here it's a much simpler model. Just call the function provided by Oracle. Characteristics of nested tables. So what are some of the aspects that define a nested table? First of all, there's no predefined or practical limit on the number of elements allowed in a nested table. The theoretical limit is about 2.15 billion elements. So positive numbers up to 2 to the 31st minus 1. These are all the valid index values for elements in a nested table. Now, the reason that, practically speaking, there is therefore no limit is that if you ever try to build a nested table with this many elements, you will blow out the memory in your session. You will get memory errors and it will crash. It's very unlikely that you'll ever have anything like this number or need to have this kind of number of elements. Nested tables are always dense initially, which means that there's every element between the lowest index value and the highest index value is always defined. However, these dense nested tables can become sparse after you do deletes, if you delete elements from within the list. As I mentioned before, a nested table type can be defined at the schema level and used as a relational table column type, or it can be defined within a PLSQL block. This is a big difference from associative arrays, which can only be used inside PLSQL blocks of code. Another big difference for nested tables is that Oracle provides multiset operators that allow you to perform set level operations on nested tables directly inside PLSQL. And that goes back to the first page about nested tables, in which I talk about nested tables being a multiset, being an unordered set of elements. If there's no inherent order, that means you have to work with them as a set. So Oracle, as of 10G, provides the multiset operators. Okay, let's take a look at some examples. Again, this file can be found in DemoZip. You can run through the same examples yourself that I'm doing, and I strongly encourage you to do so. All right, let's take a look at the first chunk of code from my nested table example script. I'm going to create a schema level list of names, which is a table of varchar 2100. And I can grant execute on that type to public or to another role or to a schema. So that's how I can allow others to use a given type. Inside my PLSQL block, I'll declare 3 different nested tables: happy family, children, parents. They're all defined on the same type, and I call the constructor function to initialize all of them to empty. Then what I'm going to do is put into the happy family list the names of all the members of my immediate family: myself, my wife, my 2 kids. To do that, I have to extend first. So there's the extend method, and it says I need 4 rows of data. Please define them for me. And since it's my first extend on an otherwise empty collection, always the extension is from index position 1 forward. So that will define 1, 2, 3, and 4. If I do another extend, it will extend 5 and 6 and so on, always past the end of the highest defined index value. Now, it's pretty rare that you will actually have hard-coded assignments like this. Much more likely you will extend 1 row at a time and then call the last method to get the new last index value and assign a value to it. So while I do a bulk extend of 4 elements here, when I'm populating my list of children, I extend and then I add the name of my child to the new last position. So that's a more common scenario that you'll run into. Okay, so I've defined my happy family. I've defined my children. Now my kids are all grown up. They've moved out of the house. So the question is, who's left? And one of the things I can do to answer questions like that is use the high-level set operators that are specific to nested tables. Here's an example. Take the happy family and minus. This is the PLSQL version of a minus, multiset except the children. And all that should be left are the parents. Whenever I perform a multiset operation, the result is a collection that is either empty or sequentially filled from index value 1. So if I want to show the parents that are left, I can go from 1 to the count for the parents collection and then display the parent name at that location, because parents again is a list of names. Let's run it and see what happens. And in fact, I see the names of the two parents, Stephen and Viva, so that worked. I started with 4, I took away the 2, and I'm left with just the parents, Stephen and Viva. So what you see here are a few different key elements of nested tables. The need to initialize, the need to extend, the very wonderful feature of these multi-set operators that allow you to perform high-level set operations, and of course the methods like first and last, next and prior, and count. Now, let's see what happens if I do some things wrong. Let's suppose that I forget to initialize. So I declare my happy family. I'm thinking it's like an associative array. I don't need to initialize those. I try to run this code, and I get reference to uninitialized collection at line 6. So notice the error didn't occur on line 2. It occurred on line 6 the first time I tried to do something with the collection, and it was uninitialized. So there's an example of a very nice specific exception. We know exactly what went wrong when that happens. Now let's suppose I say extend 3, but I try to assign a value to index value 4. I run my code, subscript beyond count. So that's too many elements that I'm trying to define. I have to make sure to extend first. So that's the error you get when you haven't extended sufficiently. Subscript beyond count. Now notice that these are all filled densely from 1, 2, 3, 4, and when you extend by default, that's how it will always work. Therefore, if you haven't done any kind of delete operations, it's actually quite safe to say go from 1 to the count, display the name. So in this case, what I've done is just change the code so that it will show the names, all the names of the happy family. And when I run this code, I see the 4 names. So again, by default, the extension always creates a list of densely filled rows in a collection, or index values in a collection. And therefore you can trust going from 1 to count to iterate through all the elements. However, it's quite possible that someone can come along and do a delete. So I can delete from inside this collection. There's nothing stopping me. And when I run this code now, I'll get a no data found exception. Because while my collection was initially densely filled, my code, my logic introduced a gap, a hole between first and last. My for loop assumes that everything is filled between the first and the count, and therefore I get the no data found exception. So when you're working with nested tables, you can't always assume that your collections will be densely filled. Depending on the operations that might have happened to them, you need to be very wary about performing things like for loops, numeric for loops, to iterate through the contents of your nested table. Okay, so that's a pretty simple example of nested tables. Let's take a look at the next part of my code here, and that is referencing the nested table inside a query. Now I've defined this collection at the schema level, create or replace type. So this is inside the Oracle database as a separate database object, and that means that the SQL layer can recognize it. And one of the other things I can do with nested tables, and also with V-arrays, but not with associative arrays, is I can select from that nested table as if it were a relational table. Now there's a separate lesson on this topic using collections inside SQL, but just to give you a brief look at it, what I've done is populated my happy family list with the members of the 4 members of my family. And then what I want to do is display the names, but I don't want to do it by iterating through with PLSQL. I want to use a select statement. So I can select the column value, that's a hard-coded column name, from. Now what I want to do is select it from my nested table. And there's a special operator called table, which is essentially the opposite of multiset. Multiset says treat this relational data as if it were a collection, a multiset. What this is doing is saying treat this multiset, this collection of data, as if it were a relational table. And then I can select the elements from it. I can order by it. I can join with other tables. It's just a regular old query at this point. And when I run this code, I see the names. Whoops, let's do that again and clear out the output, I see the names of the members of my family. And just to show you it's possible, I can say union this with select last name from employees. So I can combine this logic together, or these sources of data together. And then I see, well, a bunch of a bunch of elements of last names from the employees table, and look, there's my name. So one of the really nice advantages of a nested table and a V-array compared to an associative array is that I can actually blend together data in tables and data in my collections, or even just use SQL operations directly against my nested tables. A very helpful feature. And let's take a look at using a nested table as a column type. So what I've done here is create two nested tables, a list of parent names and a list of child names. I create a relational table called family. It has the surname or the last name of the family, the list of parents, and the list of children. So what I've done is define as columns in my table nested tables. This is an example of denormalization, and Oracle does allow you to do this pretty much as part of the object-oriented model, in which joins across multiple tables is really not a part of how you do object-oriented design. Instead, you have one object with all related data inside of it. So this kind of approach facilitates that design. When I'm working with nested tables as columns, I also have to specify a store as clause. Basically, it's a separate structure that's maintained inside the database to store the contents of this nested table offline from the rest of the data in the row. And I can even provide a storage clause, what table space it goes and how much space to allocate, etc. So this is a required aspect of working with nested table columns. Once I've done that, though, once I've defined my table, from within my PLSQL code, I can declare my local collections based on their types. I can initialize them with my constructor function. I can provide values directly in the list, the parents, the children, and then I can insert into the family table. So native inserts that don't just have strings and dates and numbers, but actually complex structures. And Oracle says, don't worry, I'll take care of all the details, and you can just do the inserts natively, run my code. Let's take a look at the family table. There's my data set, and I can open up the editor, and it shows me Stephen and Viva, the children, Chris and Eli. So the data has been directly inserted into the table. Again, this is a feature that is supported for nested tables and V-arrays. You can't do this sort of thing with associative arrays. And it's not something that most relational developers will do. We tend to work with individual normalized tables, and then we join them together. But this is an alternative that's available to you. Okay. So those are a nice number of examples. Let's move along. Valid table of table type data types. So when you declare a nested table, you say table of in the data type. For PLSQL defined types, when you define a nested table inside a PLSQL block, you can create a nested table of almost any PLSQL or SQL data type. So scalars, booleans, you can have collections of object types, collections of other collections, all possible from within your PLSQL code. However, there are some restrictions. You can't have tables of things like cursor variables or exceptions. Those don't have a state that can be stored inside a collection. In addition, if you have a schema level type, which is what we've got in the example I just showed you, a schema level type, create or replace type. With this kind of type statement, you can only have table of SQL data types. You can't have references to PLSQL types. Let's take a look. So here's an example of trying to create a list of or a table of cursor variables, weak ref cursor variables. Here's an example of trying to create a list of exceptions. Then I'm going to try to create a schema level type of booleans and a schema level type of records in the employees table. I run my code, and first it tells me index tables of cursor variables are disallowed. You can't do it. Essentially, a cursor variable points to a set of data, rows and columns, and Oracle can't store that data state, rows and columns, inside a collection. So not allowed. Table of exception, definitely not allowed. The syntax isn't even compilable. And finally, if we look at the errors for each one of these create type statements, we'll see, whoops, we'll see that Oracle is telling us unsupported type in a V-array or table type booleans, and for %row types, schema level type has a legal reference to HR employees. So the bottom line is, when you're creating schema level types in the SQL layer as a database object, you can't reference types that are not known in SQL. Unfortunately, the underlying database does not yet know about Boolean as a data type, which is kind of silly, but there's not much we can do about it. In addition, %row type is a PLSQL structure, and there's no way inside your table of to reference %row type or %type. Oracle will reject that. In fact, there's no easy way to say just create a nested table of rows from the employees table, which is actually kind of silly and an oversight, I think, on Oracle's part. But that's how it is right now. You can't directly say, I want to create a nested table of elements that correspond to the structure of a database table. Nested table is column type. I showed you one example of this just to go over a couple of the details. So if the type is defined at the schema level, it can be used as a column type. You have to provide the store as clause, which could just give it another name, giving it the name for the storage area. You can also provide an actual storage clause that provides information about how this nested table needs to be managed. If the nested table is going to be very large, thousands of rows of data, then you probably need to pay some attention to the storage characteristics. For simple, small nested tables, it probably doesn't matter very much. And there is a separate lesson talking about details of using collections in SQL, so we'll get into more detail on how you select from these structures, how you can update the structures as well. Finally, let's finish up with a little glimpse of multi-set operators for nested tables. This is probably one of the most powerful and wonderful features of nested tables, and a very strong reason to use nested tables as your collection type of choice. So in Oracle 10G, Oracle kind of fulfilled the promise of a nested table, which was to add set level manipulation capabilities. Just to understand what I mean by fulfill the promise. If you look at associative arrays, which is the most common type of collection, when you define the type, it says table of strings or numbers or dates indexed by integers or strings, so you have an explicit index by clause. With nested tables, it looks just like you're declaring an associative array is table of, but there's no index by clause, which would make you think that, well, then there's no index. Now again, until Oracle 10G, Oracle has allowed you to use an index, partly because there was no alternative. Now with the 10G multi-set operators, you can actually say, well, I'll treat it as a true set rather than as a list of elements indexed by an integer value. So you can compare nested tables for equality. You can perform union, intersect, and minus operations, and all of them have the multi-set keyword in front of them, and they're not quite like, they're quite similar to, but not quite the same as an SQL set operation. You can also check for and remove duplicates. So there's a lot of great functionality available for nested tables. I've given you a glimpse of what it looks like. We'll explore that in detail in its own lesson. So to draw some conclusions, nested tables are a type of collection that can be used inside your PLSQL code and also inside the SQL layer as a column type or even as a select from a source from a table function-based query. You have to initialize with a constructor function unless you're doing a bulk collect retrieval, and you have to extend to make room for new elements. So there's a little bit more programmatic overhead in working with nested tables compared to associative arrays. Those multi-set operators are fantastic at providing high-level set operations, which we'll pursue in detail in another lesson. Next steps: download the demo zip script, try out all the examples I showed you to explore how a nested table works, some of the features available to you, and then go exploring on your own in your own applications, and follow up with related lessons, working with collections in SQL, and also using those multi-set operators with nested tables. So I hope you enjoyed this lesson, and happy PLSQL coding.